On May 28, 1916, at the Brooklands Airfield in England, Sopwith's chief test pilot Harry Hawker climbed into the cockpit of an experimental machine that had been delivered to the site in pieces by truck. The plane's design stood out because of its three wings, stacked one above the other. The ground crew watched the preparations for the maiden flight, sizing up designer Herbert Smith's unconventional solutions, ideas that were about to be put to the test. After firing up the 110 horsepower Clerget rotary engine, the triplane took off. The test flight produced unexpected results. Shortly after lifting off, the pilot began performing a series of loops. The prototype showed high maneuverability and control while performing aerobatics. Its climb rate turned out to be just as impressive. The machine reached 3,500 meters in 13 minutes. By comparison, fighters of that era took about twice as long to do the same. After Hawker touched down, the plane was looked over by a group of engineers and military observers. The test pilot gave the machine a positive review. The three narrow wings, each fitted with ailerons, ensured high maneuverability. The wing's small chord also offered a better view from the cockpit compared to other fighters of the period. Representatives from the Royal Naval Air Service and the Royal Air Force took an interest in the development, and production orders were signed before the testing cycle was even finished. In June 1916, the prototype was sent to France for operational trials with a Royal Naval Air Service squadron. Shortly after the plane arrived at the airfield, with the technical inspection barely complete, a signal came in that a German aircraft had been spotted. Just 15 minutes after landing, the triplane took off to intercept. During this first combat sortie, flown before the plane even had its camouflage paint, the target was shot down. The machine proved highly effective. Its climb rate allowed it to attack the enemy from above, while its maneuverability gave it the edge in a dogfight. German pilots found themselves facing a machine with an incredibly fast turn rate. The pilots of the Royal Naval Air Service praised the new fighter and recommended immediate mass production. In February 1917, production models began reaching the 8th and 9th Naval Squadrons. These planes were equipped with a 130 horsepower engine, which boosted their performance. Their armament consisted of a single synchronized Vickers machine gun firing through the propeller. By April, the triplanes were seeing action in 6 squadrons, with reports confirming their success in aerial combat. At the same time, the design was being refined. In February 1917, an order was issued to replace the tail assembly on all units, including those already in service and those still on the assembly lines. Modifying the tail assembly by reducing its size improved control response, allowing the aircraft to execute vertical dives, a maneuver that had previously presented a technical challenge. This design change boosted the machine's combat potential, enabling it to attack targets from various angles and altitudes. In the spring of 1917, a squadron began operating on the Western Front that significantly influenced the operational situation in the sector. Number 10. Squadron of the Royal Naval Air Service was re-equipped with new triplanes, and one of its flights adopted a distinctive look. Flight Sub-Lieutenant Raymond Collishaw led a group of 5 pilots whose planes, specifically the engine cowlings, metal fuselage panels, and wheel covers, were painted black. The formation was designated the Black Flight and became a serious adversary for the German Air Force. The characteristic coloring of the triplanes allowed German pilots to visually identify this group from a distance. Visual contact with these aircraft meant engaging in combat with skilled British airmen. Collishaw selected pilots for the flight who had active combat experience and a drive for results. The group's tactics were built on leveraging flight performance. Utilizing the triplane's high climb rate, the flight would position itself above the enemy, then attack from above using its advantage in maneuverability during close combat. The unit proved highly effective. Between May and July of 1917, in just 3 months of active sorties, the Black Flight destroyed 87 German aircraft. According to archival records, these are confirmed aerial victories. Collishaw scored 33 aerial victories flying the triplane. Out of his total of 60 confirmed kills during the entire conflict, more than half were achieved while flying this 3-winged machine. This made him the most successful pilot to ever fly the Sopwith Triplane. German aviators reported back to command about encounters with a new type of fighter, one that outperformed their own aircraft. It was noted that the British triplane had a much tighter turn radius and a faster climb rate than the enemy's equipment. These qualities allowed for effective attacks and quick changes in position, leading to losses among German crews. The reports coming in from the front caused serious concern at German headquarters. Recognizing the potential of the design, the leadership initiated the development of their own version. This marked the beginning of the Fokker Dr.I, the model later flown by Manfred von Richthofen. However, throughout the spring and summer of 1917, while the Germans were just getting started on their three-winged machine, the British held the initiative. There is evidence that German pilots were ordered to avoid direct combat with these aircraft unless they had a clear numerical advantage. In this way, the psychological impact of the new technology was just as significant a factor as its engineering features. The leadership of the Royal Naval Air Service and the Royal Flying Corps reached an agreement on the redistribution of equipment. Initially, both services had placed orders for a large number of triplanes, but by early 1917, the tactical priorities of land-based aviation had shifted. As a result, the decision was made to transfer all triplanes intended for Army squadrons to the fleet in exchange for an allocation of French Espada 7 fighters. This meant the Sopwith Triplane was flown exclusively by naval aviation and never saw service with the ground forces. These machines continued to see action on various sectors of the Western Front, where many pilots racked up high scores. The aircraft proved to be so combat effective that the enemy often avoided direct engagements, preferring to target other British fighter models instead. The narrow-wing design offered excellent vertical visibility, which gave an advantage in dogfights, and having ailerons on all three wings boosted controllability, allowing pilots to execute complex maneuvers rapidly. Nevertheless, this aircraft had technical limitations that became increasingly obvious over time. Carrying a single Vickers machine gun provided insufficient firepower compared to the new German fighters, which were starting to feature two synchronized machine guns. Attempts were made to mount a second weapon. 6 units are known to have had this heavier armament, but this modification never became the standard. Furthermore, the three-wing design created difficulties for repairs in the field. The supply of spare parts was a real problem for mechanics on the front lines. Even minor damage to one of the wings entailed extensive work to replace or restore it. Unlike biplanes, where a wing change was relatively quick, the triplane required careful balancing of the entire lifting system. Any distortion in the frame's geometry led to reduced flight performance or a loss of control. The logistics for spare parts were irregular, and production rates lagged behind the demands of the front, meaning damaged aircraft could sit idle waiting for necessary components. The situation was complicated by distributed production. Manufacturing was handled not just by Sopwith, but by licensed contractors as well. Clayton and Shuttleworth produced 47 units. Oakley and Company made 3, and Sopwith themselves built 95 aircraft, including 2 prototypes. The total production run was 147 machines, which was a comparatively small number for a conflict of such scale. Products from different factories had structural differences, which complicated repairs and supply standardization. Maintenance crews periodically found it impossible to swap parts between aircraft from different manufacturers. By the summer of 1917, it was becoming obvious that the triplane's design potential for further modernization was practically exhausted. At the same time, Sopwith was finalizing a new fighter, the Camel. It was designed to combine the maneuverability of its predecessor with the simplicity of a biplane layout and heavier armament consisting of 2 machine guns. This new model was easier to manufacture, more economical to maintain, and packed more firepower. The command of the Royal Naval Air Service decided it was time to overhaul the fleet. In July 1917, Naval Squadrons 7 and 8 were the first to start swapping their triplanes for Camels. Retraining the personnel went quickly because of the similarities in flight characteristics, although the new machine was much more strictly controlled. It demanded high concentration from the pilots and didn't forgive any mistakes. Gradually, the triplanes were transferred to rear units, where they were used for training pilots and conducting tests. By November 1917, operations with these machines on the front line had ceased completely, even though their active combat career lasted less than a year. This type of aircraft had a significant influence on the development of military aviation at the time. Its geography wasn't limited to the Western Front either. One plane was sent to the Aegean Sea, assigned to the Royal Naval Air Service's No. 2 Wing, stationed on the island of Mudros. The aircraft patrolled the waters and provided air cover for naval forces against the enemy. The Mediterranean climate proved to be much more favorable for the wooden airframe than the conditions in Flanders, allowing this specific plane to remain in service longer than its counterparts in the West. Several triplanes found their way into Allied hands. The French received at least 4 aircraft, using them for testing and training their pilots. Although the pilots praised the British fighters' maneuverability, command preferred to focus on their own domestic aircraft, the Nieuport and the Spad. In May 1917, a single unit was sent to the Russian Empire, whose leadership was showing a keen interest in Allied technical developments. Once there, the plane underwent a structural modification. Instead of standard wheels, skis were installed for winter operations. This version was one of a kind. During a series of test flights, the machine showed impressive results, despite the increased takeoff weight from the ski landing gear. The climb rate dropped slightly, but the overall flight performance remained high. Due to the political events in the country, further cooperation ceased and mass deliveries of the aircraft never took place. The ski-equipped model survived through the years and was eventually transferred to a museum collection. After being withdrawn from combat duty, the remaining aircraft of this type were used for training purposes. Pilots trained on these machines, practicing aerobatics and adapting to the stresses of real combat. Thanks to its forgiveness of pilot error, the model proved itself to be an effective training platform. Individual units were used for experimental work, including the testing of new engines, radios, and various types of weaponry. In particular, attempts were made to install rocket weaponry, though these experiments did not yield positive results. By the end of the fighting, most of the triplanes had been written off, stripped for parts, or scrapped. The wooden elements were used as fuel, metal parts were sent to be melted down, and the fabric skin was burned. The military didn't need these planes anymore, as they had been completely pushed out by the next generation of fighters. Only a few machines survived. Today, just 2 original triplanes remain. One is on display at the Royal Air Force Museum in London. The second is located at the Central Air Force Museum in Monino. That's the specific one that was sent to Russia and fitted with skis for landing gear. The Sopwith Triplane's impact on aviation turned out to be much bigger than you'd expect, given its short service life and the limited number produced. The arrival of this model pushed German engineers to rethink how they designed fighters and start building their own triplanes. Even though it showed up later and had a different design, the Fokker Dr.I was a direct technical answer to the British triplane. It's worth noting that seeing these machines on the front lines in the spring and summer of 1917 had a major psychological impact. Design-wise, the triplane leaned heavily on technical solutions the manufacturer had already tested. The fuselage was almost identical to the Sopwith Pup, a fighter that had already proven itself to be reliable and maneuverable. At first, they borrowed the tail section without any changes, but later on it was swapped out for a custom design with a smaller surface area. Using standardized parts allowed them to significantly cut down the time needed to develop and produce the new model. The aircraft's key design feature was the use of 3 lifting planes instead of the traditional 2. Each wing featured a narrow chord, the width of the profile from the leading to the trailing edge. This technical solution went against the accepted practice of the time, when biplanes used wide wings to generate the necessary lift. Chief designer Herbert Smith calculated that 3 narrow planes would provide lift comparable to 2 wide ones, while significantly improving the pilot's field of view. Practical operation proved these calculations correct. The improved visibility allowed the pilot to monitor the airspace more effectively, giving him a tactical advantage during maneuvering. All 3 wings were equipped with ailerons for roll control, which was a rare feature. On most biplanes, control surfaces were located only on the upper wing. Having a triple set of ailerons ensured a rapid response to control inputs. When the stick was moved, the aircraft began its maneuver almost instantly. This high roll rate required a certain level of skill from pilots as well as time to get used to the sensitive controls. In combat conditions, this responsiveness was considered a significant advantage, allowing for rapid changes in flight trajectory. The structural framework of the wings was attached to the fuselage by a system of struts and metal bracing wires forming a rigid truss. The gap between the planes was selected based on aerodynamic requirements. Spacing them too closely could cause harmful airflow interference, reducing lift, while spreading the wings too far apart would add unnecessary weight to the structure due to the longer struts. Sopwith engineers developed a design where, despite aerodynamic interference, the three wings functioned practically as a single lifting surface. A key feature of the layout was the adjustable stabilizer. The pilot could change the angle of the horizontal tail right in the middle of a flight, balancing the machine so it could fly without constant input on the controls. This solution helped reduce crew fatigue during long patrols that required constant alertness. With the stabilizer angle set correctly, the plane stayed on course, which allowed the pilot to focus less on flying the machine and more on scanning the sky. The Clerget rotary engine, common on fighters of that era, had a unique way of operating. Unlike stationary engines in this unit, the entire cylinder block rotated along with the propeller around a fixed shaft. The rotation of a significant mass created a strong gyroscopic effect that affected the aircraft's handling. Because of this, the plane turned easily in one direction but took a lot more effort to turn the other way. Skilled pilots adapted their tactics to this quirk, using that quick turn to their advantage. The armament consisted of a single 7.7 millimeter Vickers machine gun mounted right in front of the cockpit. It fired through the propeller arc using a synchronizer. This mechanism stopped the gun from firing the moment a blade passed in front of the muzzle. With the system working smoothly, a single gun had a rate of fire of about 600 rounds per minute. Using twin mounts pushed the total rate to 1,200 rounds per minute, increasing the chances of hitting a maneuvering target. The ammo load was just a few hundred rounds, which allowed for only a limited number of attacks. To make up for the lack of firepower, triplane pilots used the tactic of closing in on the enemy to minimum range, ensuring high accuracy. Their outstanding maneuverability allowed them to get on an opponent's tail and hold that position no matter how hard the target maneuvered. A skilled pilot could keep a distance of just a few dozen meters to deliver methodical fire. Moves like that required serious composure, but they were highly effective. Compared to the German fighters of the time, the British machine was clearly superior in maneuverability and climb rate. The German albatrosses were faster in level flight and had heavier weapons, but they couldn't match the triplane in vertical maneuvers. Realizing they were outmatched in a vertical fight against the triplane, German pilots tried to avoid these situations entirely since the British machine could climb rapidly to attack from above. The only way for the Germans to break off an engagement was to use their superior speed in a dive. Unable to beat the triplane in a climb or a dogfight, the German command ordered the urgent development of their own version. Fokker received the contract for a three-winged fighter, and the project was fast-tracked. The German designers took a different approach. Their plane had wings without external bracing. This improved the aerodynamics, but it meant the internal structure had to be reinforced. The Fokker Dr.I entered service in the fall of 1917, just as the British triplanes were already being phased out of action. The triplane's ease of handling made it effective for both seasoned pilots and newcomers who had just arrived in the combat zone. The aircraft's design forgave many piloting mistakes that might have led to a crash in other models. Spins were rare, and recovering from them was straightforward. Landing was simple thanks to a low landing speed and excellent downward and forward visibility. It needed only a short takeoff run before transitioning into a rapid climb. In the fall of 1917, British naval squadrons began a mass transition to Sopwith Camel fighters. The 9th Naval Squadron was one of the last to replace its triplanes. The flight crews spoke highly of the outgoing aircraft, marking the end of active service for this type of plane. According to a number of pilots, the triplanes showed the highest combat effectiveness of any aircraft available to them. They pointed to the model's rare combination of maneuverability, climb rate, and handling. The final combat sorties took place in October 1917. Until they were retired, the machines were used to patrol over troop positions and intercept enemy reconnaissance aircraft. Despite becoming technically obsolete, the plane remained combat effective in the hands of a skilled crew. By November, all remaining serviceable units had been redeployed to the rear to be used for training. Unserviceable aircraft were stripped for parts to maintain the ones still in use. 6 aircraft, experimentally equipped with a second Vickers machine gun, were retained to test various armament configurations. The engineers tried to find the best way to mount a second machine gun while maintaining the aircraft's balance. Tests showed that the added weight of the weapon and ammunition reduced flight performance, particularly the climb rate. The triplane was losing its primary advantage, becoming just an ordinary fighter by comparison. For this reason, the twin-gun version never went into mass production, despite the logical need for increased firepower. Training units continued to operate these planes until the spring of 1918. Flight school cadets gained experience piloting a combat machine before being sent to the front lines. The triplanes were used to practice aerobatics, dogfighting maneuvers, and gunnery against ground and air targets. The sturdy design held up against the hard landings of student pilots, though accidents still happened periodically. The fleet of operational machines gradually shrank due to breakdowns and a shortage of spare parts. By the summer of 1918, only a few individual planes remained in service. Production had ended. Parts supplies were exhausted and maintenance crews had shifted to servicing newer types of equipment. The remaining triplanes eventually fell into disrepair, sitting in remote corners of airfields, exposed to the elements. The wood rotted, the fabric covering was torn apart by the wind, and the metal parts rusted away. There was no longer a need for these machines, as the war demanded a constant stream of newer, more advanced aircraft. The Sopwith Triplane went down in history as the first and only triplane fighter to enter British service and see actual combat. Its arrival in the spring of 1917 caught the enemy off guard, forcing the German command to rethink their entire approach to fighter design. The triplane's combat record proved that unconventional engineering could be highly effective. Raymond Collishaw's unit, known as the Black Flight, scored 87 aerial victories in these planes in just 3 months. Today, 2 original survivors are held in museum collections, standing as historical testaments to the aviation technology used during the fighting in Flanders. There are also several modern replicas built by aviation experts. These planes still take to the skies at air shows, demonstrating the agility of this unique 3-winged fighter.